Alright, so now we have a way to have any amount of data that we can process with the for loop one at a time. The processing of each element depending possibly on its position and its value and the values of its neighbors. So a lot of data is of this kind of a nature that we need to be able to access it by position or just iterate through from beginning to end. But in many situations I would need a different operation on the data because I need to keep track of the things that I have seen and done before during the execution of the function. So I would need a way for the data to organize itself, not necessarily in a row, I don't care about the positions, but the data organize itself in a way that I can quickly call the name of an element and ask, is this element present in that data structure, yes or no? And I want that yes or no answer just to come quickly. I don't care what kind of patterns the data internally organizes itself. So that is the data type of a set. So a collection of elements whose internal ordering doesn't matter to me. I just want to be able to quickly call elements by their names. And now, okay, so here is a comments because they never executed, so I don't get an error message. So set is like a list, so word is missing, but it will like a list, like a whale is a fish, I guess. But so the set, the idea is that the operation in and not in, testing the membership. So this one for just the list would be extremely inefficient because the list to determine if the element is there when any element can be anything is to just look at the elements in order one by one and see if any one of them is the one that we're looking for. So for a long list, the in operation, and especially whenever it's failing, returning not present, then it's gonna be very slow. So this data structure set is optimized for the quickly asking whether an element is in the set or not in the set. And that answer for all practical purposes for this discourse comes in the guaranteed constant time, even if you have a million element set. So this asking if an element is present is a constant time operation. Not really, but the relay is so small that it doesn't matter for us at all. Okay, so now how do we make a set in a Python? The curly braces, characters that we haven't been using for anything so far in the Python syntax, unlike many other languages. Now the curly braces unused, now they're gonna be denoting a set. So here we have a set. Now the set could be heterogeneous, but here so a set where every element is a string. So we have a set of names Larry, Johnny, Billy, Mary, and Larry. But so here, so the set, the element either is or is not, and if it's a member, so adding it another time don't make it any more of a member. So the membership is just a yes, no predicate. So then this is actually a 4-element set because the Larry is in the set only once. So here then we have a 5-element set with some elements in common and some elements in uncommon. So it doesn't really show in a small example, but the idea of the set is that the membership check, this operation that we need, so this is gonna be as fast as it can be made. So we always quickly can tell whether something is part of the set. And we can read through the documentation page in the standard library documentation. The language, so then the set data type, it contains methods for various set theoretical operations, so we can calculate the union difference and the intersection. So if it's like we will now do some new math or something, go to the 70s again. You can iterate also through the set. Now, unlike a list sequence that guarantees that your iteration processes the elements in the guaranteed order from left to right, so the order in which the set produces the elements I think this may have changed in a recent Python. I thought that so, but it is at least used to be that the order is implementation dependent. So the hash table data structure that is inside the set, so that's gonna be explained in the algorithm. But so that data structure has a lot of freedom of operation. So the order in which you get the elements is actually implementation defined. So then you get this for loop produces all the elements in the set in some particular order. Generally, when iterating through a set or a list, modifying the contents of the set and the list inside the loop is not a good idea. Sometimes it might work, but usually it doesn't. Okay, so the set is quickly for the membership. And typically we'll use it, keep the thing of the set things that we've seen, and every time we see something new, then we add it to the set. So then we can quickly recall if we already seen something before. A dictionary is like a set, but it's like even more powerful. So in a set, the key membership was a yes or no, and in a dictionary, the membership is that if you're a member, so you get to also carry one piece of luggage with you. So the value that you are associated with inside the dictionary. So dictionary, so a mapping, so the different languages call this a different thing. Something that associates the key values, the members of the dictionary, to their associated values. And here as an example, so we could use it to implement the scoring table when we have an unknown number of players. So maybe in the later in the game, so some new players might join in, so then the dictionary would grow, and to each current player, so we would keep the track of the current score. So let's say initialize the fictional situation that we have these kind of scores in our fictional game. And then so notice, by the way, it's the same curly braces as with the set, but it is just the fact that you make this kind of items there. So it's the fact that makes a dictionary. This empty is just a dictionary. Okay. So now the beautiful thing about this dictionary, so is that it's like a generalization of a sequence. A sequence is a mapping. It is mapping small consecutive integers into the values. But so a dictionary can map. So these keys could be anything. These could be integers, but because they can be anything, so a dictionary is a more universal mapping from some kind of keys to values. But the exact same syntax as with the slicing, but now we just use an arbitrary value as so in the dictionary, what is the value associated with the key Mary? And then so if let's say this is a counters or scores or something, so whenever we update the score, we say that the score currently associated with Lena, so is the previous score plus 5. Now here we have to be careful though, this is a bit annoying. So this accessing the value, so what happens if the key is non-existent? So then this crashes, throws whatever exception, I forgot. So the safe version, so if in place of this one, so if you use the method get instead of the square brackets that just dive in and then they might crash. So ask for a value, and if the value is not the key value is not present, pretend that it was there associated to this default value. So we say that the score of an unknown player, so who's not part of the dictionary, is initially 0. So if you for loop through a dictionary, you actually go through the keys, and then you can also loop through the key value pairs. And then whenever I ran this and put those comments, then in that particular time and that particular virtual machine implementation in my particular computer at that particular time, so the outcome of the hash table ordering happened to become that one, and then so it was this way. Couple of pitfalls for the equality, so this dictionary is this was in a Stack Overflow somewhere, I don't know why. If you wanna shoot yourself in the foot, so in any programming language you can always do so.